Hello everyone, so in this video we will be discussing Jacobi method. So Jacobi method is just another way of solving our system, our linear system, and this is still under the iterative method. And Jacobi method is just really related or mostly similar with the Gauss-Seidel method. It's just that they will differ in some processes later on. So again, using this one, we have basically it's the same with the Gauss Seidel. You still need to find or you still have to have the diagonal dominance for this one, meaning to say kailangan mas malaki yung value ng diagonal ng coefficient ng diagonal elements natin kesa sa ibang elements ng linear systems natin or ibang terms ng linear systems. So again, we need to have our diagonal coefficients to have the larger number than the other terms of our system. So basically, I just use the same content with the Gauss-Seidel method. You still need to find the formula for the x sub 1 and the x sub 2 and the x sub 3, or that could be x, y, or z, depending on what is asked from our linear system. So if you are still quite unsure with how this goes, you may also review the previous videos, the Gauss-Seidel method video that I also uploaded in our LMS and in YouTube. So basically, that's similar. They are similar lang naman. So we have here an example. Use the Jacobi method to solve the following system until the percent relative error falls below 5%. So I still used the same linear systems I used from my Gauss-Seidel method video so that we can see what will be the difference of the result of solving our linear system using Jacobi method and the difference between the result of our Gauss-Seidel method. So now we'll start with the Jacobi method. So basically, again, from this linear systems that we have here, we need to find the value of our x sub 1, x sub 2, and x sub 3. So from here, again, we need to isolate our x sub 1. So we can have our x sub 1 is equivalent to 27 minus 2x squared plus x sub 3 all over 10. So this is already our x sub 1 formula. Now, we also need to find our x sub 2 formula, which is this one. We have negative 61.5. We also have plus 3x sub 1. And we have minus 2x sub 3. And the coefficient of our x sub 2 is negative 6, so we also have to divide it by negative 6. So that gives us equivalent of 61.5 plus 3x sub 1 that should be plus, and this should be minus. It's what I did was we have 6. Negative divided by negative, that is positive. Positive divided by negative, that should be negative 3x sub 1. Negative divided by negative, that is positive 2x sub 3 divided by our positive 6. So this is now the formula of our x sub 2. Now for the x sub 3, we also have equivalent to negative 21.5 minus our x sub 1 minus x sub 2 all over the coefficient of our x sub 3, which is 5. So that being said, we have this formula, our x sub 3, our x sub 2, and our x sub 1. So we will still be using this formula later on for the substitution of our values. So we still have this one, 5% is still our EK. or our relative error. So that is equivalent to 0.05%. So meaning to say, our relative error must not be greater than or equal to 0.05. It should always be less than 0.05. So assuming we have here our we can have here our n, or the number of iteration, or the k. Let's just use this one as k. So we have the k here. We have the value of our x sub 1, the value of our x sub 2, the value of our x sub 3, and we also have our relative error in terms of x sub 1. Basically, getting the relative error that has the same formula with getting with all of the systems or all of the methods. So meaning to say, from Gauss-Seidel, if the relative error formula is equivalent to e raised to x, x raised to k plus 1 minus x raised to k, that is still the same here in our Jacobi method. So again, that is the absolute value of our x k plus 1 minus our x raised to k. So the same formula with Jacobi method. So we'll still be using that one. And then we have the k for the x sub 2, which is still equal to this one, and e raised to k x sub 3. So we have now this one, and what we just need to do is to find the values of them, or to find the values of each of them. So we have just this one, this one. Okay, so for the first iteration, we will be having an initial value of all zeros. And then for the first iteration, we will be substituting now all the zeros here into our formulas. So from here, we have our x sub 1 is equivalent to 27 Dao minus 2 times our x sub 2, which is 0, plus our x sub 3, which is 0. That's divided by 10. So that gives us the value of 2.7. So meaning to say, we need to put our 2.7 here. And then same process with the x sub 2. So we have to substitute again the value of our 0. So unlike the Gauss-Seidel method class, na what is the latest value, kung unsa tong latest value sa x sub 1, mao po din yung gamiton nga value for the substitution. No. In Jacobi method, kung unsa tong gi-substitute nato, or unsa yung previous value, mao dapat ang ato ang gamiton. So meaning to say, kani nga linya, this line is the only values that we will be replacing, or we will be using in substituting into our formula. So again, for the x sub 2, we have here 61.5. Unsa naman ne? So just erase that one. So again, we have 61. We have here the 61.5. So meaning to say, in our x sub 2, we also have 61.5 plus 3, and then x sub 1. Again, in Gauss-Seidel, kung Gauss-Seidel atong gamiton na method, si 2.7 is the value that we will be substituting in our x sub 1. But no, since this is Jacobi method, then we will still be using the previous value, or the first, or the initial value that we have, which is 0. And then we have minus 2, and then our x sub 3, which is 0. So that is divided by I am following this one. No, that should not be. This should be minus and this should be plus. So minus and then plus and then 6. So that gives us equivalent to 10.25. So meaning to say, kanina po ang atong i-substitute, ato ang ibutang dere, which is 10.25. Now, we also have the XL3, which is equivalent to negative 21.5 minus x sub 1. Again, our x sub 1, the value that we need to use is 0. And for the x sub 2 as well. So we have divided by 5. So this gives us the result of negative 4.3. So that is what we will be going to write here, 4.3. So basically the same process for the relative error. So we have now this line or this value here minus the value of our 0. So we have the x k plus 1, so that is 1, minus x raised to k, which is 0, so that gives us 2.7. The other one is 10.25. And the other one is 4.3. Since this is an absolute value, meaning to say there's no need to copy the sign for the relative error. So the same process, we need to do the same process all over again until such time our relative error now will be less than 0.05. So since that is not yet less than 0.05, then we'll continue with our iteration. So we have to substitute now this one. The x sub 1 is equivalent to 27 minus 2. And then our x sub 2 now, kanina pod nga line ang atong gamiton. So 10.25 plus XL3, which is negative 4.3, divided by our 10, which is equivalent to 0.22. So following the same process, again and again, same process, we have the x sub 2 now, which is 61.5 minus 3 times x sub 1. Again, dili kani ang latest value nga atong gamiton. Katog yapong nasa first row or nasa iteration 1, which is 2.7. And plus 2 x sub 3, which is negative 4.3. That divides by 6. So that is equivalent to 7.46667. So basically, you should have again to write 6 decimal places or 6 digits and the decimal points, and that for the x of 3, substituting the values again. So we have the x of 3 is equivalent to negative 21.5 minus x of 1, which is 2.7, minus our x of 2, which is 10.25. That is divided by 5. So that gives us negative 6.89. So for the relative error, we have 2.48. We have 2.783333. For the other one, we also have 2.59. So again, this is not yet done because we are still not done with the relative error. So we need to substitute again for the third iteration. So this is following the same process. This values na po ang ato ang gamiton. Kaning values na naa sa 2. Which is this one. So by that, using the same process, we have 0.5176 667. And for x sub 2, we have 7.84. 3, 3, 3, 3. We also have negative 5.89. I'm sorry, that's 5.83. 7, 3, 3, 3. And for the relative error, now we have 0.29, 7667. And for the relative error for the x sub 2, we have 0.371234. And for the other one, we have 1.052667. So that's it. Now, as you can see, no one from our relative error is still less than 0.05. So we need to continue the iteration until for the fourth iteration. So we have 0.5476, 00. We also have 8.045389 minus 5.9722. And for the relative error, we have negative. No, we have 0.29933. For the other one, we have 0.202056. And we also have 0.134867. So moving forward, we already have the values of our 5 here, or the iteration, or the fifth iteration. So as you can see, this is already 0.05389, as well as this one 0.05. But as we know, or as we have in the problem, the percent relative error falls below 5%. So meaning to say, we still cannot accept the relative error that is approximately equivalent to 0.05. So we just need to find again the much lower, or pinakagamay, or mas gamay pa sa 0.05. So since ang isa sa atong mga values diri is naapa sa 0.05, meaning to say we cannot stop yet. So we need to continue again with our iteration. So we already have the sixth iteration now. So we have 0.501047, 7.99695. The other one is negative 5.995834. And the other one, and for the relative error, we have 0.007345. And we also have 0.01, 1483, 0.011483. So as you can see here, we already have the values. The relative error here is already less than 0.05. So meaning to say, we can already stop our iteration. But again, class, Dili pasabot nga if nakakuha na kag less than 0.05 diri, either one of them is mag-stop na ka. No, the three relative errors should be less than 0.05. Dili pasabot na 0.04 na ning relative error for the x of 3 na pwede na mo mag-stop. No, you need to stop when all the relative errors that we have is already less than 0.05 or less than our threshold value for our relative error. So meaning to say, if you already find or if you already have the result that is less than 0.05 for all the relative errors, meaning to say you already have your answer. So that gives us our x sub 1 is this. This is our x sub 2. And this is also the result of our x sub 3. So again, this is our x sub 1, this is our x sub 2, and this is our x sub 3. Now comparing that one to the result of the Gauss-Seidel method, I have here the screenshot of the result of that one, which is this one. So as you can see, the result is 0.49 and this one is 0.5. The other one, the x sub 2 is 7.97 and the other one is 5.995241. So as you can see, they are really approximately equivalent with each other. So, but in the Gauss-Seidel method, we only have 4 iterations, then we already got the answer. But in the Jacobi method, we have 6 iteration before we get the answer. But that does not mean that Jacobi method is much longer or will take much longer iterations than the Gauss-Seidel method. It may vary depending on the values or depending on the given. So this is just another way of solving for the linear system. So we have this one and we also have the Gauss-Seidel method, which was already solved from the previous videos or from the previous video that I've posted. So those are all the discussions for this video. So I hope you learned something, or if you still have any confusions or questions in your minds, don't hesitate to message me in Messenger or in our LMS. So that's it for this video and hope to see you around.